Okay. So we're back here. What, we get x equals negative of negative 12 plus or minus the square root of 12, negative 12 if you wish, squared, minus 4 times 1.7 times 17.7. All that divided by 2 times 1.7. Okay? Well, your axis of symmetry should be what?
Should be
12 over 2 times 1.7,
Yeah.
right? 12 over 3.4. Well, 12 over 3 is 4, 12 over 4 is 3, so it should be somewhere between 3 and 4. Where is it? It's somewhere between 3 and 4, so we're at least that accurate, right?
Ooh.
So just a quick check on the axis of symmetry. Okay, and 12 over 3.4 is going to be about 3.6.
52941.
Yeah, I was going to say 3.6. So 3.6. If we go back to our original graph and let's take a quick look at that. Yeah, 3.6 would be about here. So it isn't great,
Could be
but it's not terrible either, okay? Considering the approximations we've made and the fact that the graph isn't really that great of a parabola anyway. And, you know, our scale over here is screwed up, so our linear function is messed up, right? So the fact that we have all those little errors and we're only off by that much in our axis of symmetry is promising. Okay. And then we could see if the average of these 2 points here is close to our axis of symmetry, right? Okay, if you add these, you get 7.3. Divide that by 2, you get 3.65, which is awful close to our axis of symmetry, 3.6. And I hope you understand what I just said. It's worth looking at the videos to get these little subtleties that might be helpful to you. But of course, I know you have limited time, so weigh that out. Okay? Okay, so there's our axis of symmetry. So our zeros are at the axis of symmetry plus or minus this square root divided by the 2 times 1.7. Okay? Now, this is 144. 1.7 times 17 would be 28.9. That's a little more than 17. So I'm going to say that's about 29. And 4 times 29 is 136. Okay? Which would make this maybe 8. Now, there's a lot of potential error in that approximation. Okay? Because 8 isn't that big a number, so I'm off by 1, I'm off by a fairly large percent, even though I am taking the square root, which helps a little bit. But that equals 3.6 plus or minus 2.8 over 3.4. Okay? Well, that's really kind of bad, because that's nowhere near these points. Okay, so it could be that I messed something up. Okay, and actually I did, because 29 times 4 is not 136. Okay, it's 116. So there's my big old margin of error, right? So let me fix that. Okay, 116 from 144 is 28. And now, because we wouldn't be that close to the axis of symmetry and that far off, okay? So square root of 28 is about 5.3, and 5.3 over 3.4 is approximately 1.5. It's a little more than 1.5. So that's 5.1 or 3.1. Okay. 2.1, sorry. This blue erases badly, especially with my thumb, which is all blue. So we get x values 5.1 or 2.1 for the points of intersection, don't we?
Hey.
Now, what were our estimates?
5.1 and 2.2.
Well, Jaheen nailed this one, 5.1, right?
Your
And
estimate
whoever
was-
estimated 2.2 really screwed up because it's
Wow,
2.1.
thanks, y'all. Y'all wanted to say 2.3, so I was closer.
At least you know, influences back into the
Yeah.
nearby realm. Well, that's actually pretty impressive, right? Okay? So, despite all the flaws in this thing, things worked out, and we've also illustrated how you find the point of intersection of two graphs, right? Either by estimating or by using the equations, okay? Now, there's more we can do. We still have to find the y-coordinates, right? That's where I'm a little fearful, but, you know, things have worked out really well so far. You know, if your estimates and your equations work out this close, you're doing really great. And if they're closer, you're doing even greater than I am. And that's just, you know, music to my ears. Okay, so let's see what we get for the y-coordinates. Okay, so this book's going to fall over if I take it over any further. We'll bring it back if we need it. Okay, so what's our status? Intersections when x equals 2.1. And when x equals 6.1. Okay? So, now we want to find the y-coordinates. Y equals 0.91x plus 1.36 gives us 0.91 times 2.1 plus 1.36, and y equals 0.91 times 6.1 plus 1.36. Okay? 0.91 times 2.1 is pretty close to 2. So that would be like 3.36. And yeah, the estimate over there was 2.5, so that's a little off. And this is going to be pretty close to 5.5, and that's going to be like then 6.36. Okay? Now, what were our estimates? Well, with the 5.1, and is it 5.1 or 6.1? It's 5.1.
It's 5.1.
So I wrote it down wrong. It's 5.1. So actually, you know, 6.36 would have been really close, but it's really 5.1.
So you get like 6.91.
So we've got to make this 5.1. So this comes out, that's like 0.46 and 1.4. It's about, it's 4.6, 1.4. It's about 6.
It's like
Okay.
6.00.
Yeah. So that's still not bad. Okay?
Yeah, 6.001.
So
So
let's
basically-
compare with our estimates, which were 2.2, 2.5, and 5.1, 6.3. Okay? So the 2.2, 2.5, well, we got 2.1, 3.36, right? Okay?
So that's 2.1.
So the comparison would be with this and 2.1, what did I say again? 2.5. No, 3 point, that's about 3.4. And this, we would compare with 5.1, 6.3. Okay? Now, the other thing we can do is we can plug the same values into the quadratic. Okay? Now, if we had an accurate solution here, if I hadn't been making approximations, we'd get exactly the same thing when we plug in to the quadratic side of the equation. Okay? We won't, and I'm not going to go through that. You can do that yourself. We're not going to get exactly the same thing, but they should be pretty close. Okay, so what's the bottom line?